All right, welcome back. So we saw last time how we can filter data by using the where clause. With the where clause, you can use comparison operators like equal sign, not equal sign, which is usually like this, or you could also do this symbol, and then you could do greater, smaller, greater or equal, less than equal. And these are basically the comparison operators that you can use. They're pretty much the same as any programming language. Actually, there is one thing that's new. Usually in programming language, because you can assign certain things, this is usually the assignment operator, and then the equal operator will be like this. But for SQL, that is not the case. We never assign anything on SQL, so we use the normal equal sign. So yeah, so that's the only thing that you should remember. All right, let's check out a few examples. So here, like we had last time, what we did was we wanted to look at all the orders that are less than $1,000 USD. So here's what else you can do. You can also do maybe more than 1,000. There you go. Now you get only rows that are above $1,000. And then one thing you can do is also equal sign. You probably won't get anything because there are no orders that are exactly $1,000, but let's just try. Yep, there's none. Okay, so let's take that out, put larger than. And then I guess what we can do is we can filter on quantity. So let's make the quantity exactly 288. So you should see this row. All right, let's try to remember it, $1,718. Okay, we'll delete that. Rerun it. We should have at least one row. Oh, we have 7 rows actually. That was the one we were looking at. And here are the other orders that also have 288 as quantity. Equal signs are pretty useful. I mean, I guess what you can do, you could choose a specific account. For example, 1561. I chose 1561 because of this one. All right, let's run it. Let's see how many orders they have. They have 68 orders. Okay, that's interesting. You could also do the opposite, where the account ID is not 1561. We run that. Okay, and there you go. All right, so now we have every account except for this one, the 1561. Let's just try this one out. It should give you the same thing. I usually prefer the exclamation mark and equal sign, since in most programming language, that's how you do it, but it's your choice. Now, let's try to find another table. Let's do city population instead. City population, let's see all the cities. Now, you can also do these comparison operators on strings, like for example, the city and state. So let's filter on state. Oops. State is not equals to New York. Run that. The New York one should be gone. Oops. So the reason why this didn't work is because in this SQL version, column names are double quotes and then values are single quotes. So you got to remember that. If ever you want to represent a string, you have to use single quotes. All right. So here, as you can see, New York is no longer here. Right? There's 49 states now. So I guess what you can do also is have a greater than. What does that mean? So for strings, it just uses the alphabetical order. So example, the letter A comes before B, so B is greater than A. So as you can see, for all the states that are greater than NY, New York, these are all the states that start with the letter that is greater than NY. All right. So what happens if you do like this? State is bigger than N. What will you get? You are going to get New York. And the reason is because New York has 2 letters and N has only 1 letter. So N plus Y in some ways, that's how you calculate it. So that means NY. The numerical value for this string is larger than N. You could think of it as ASCII code, where, for example, let's see, N ASCII value. So the N ASCII value should be 78. And then because it's 78 and then the next letter is empty, so you could think of it as 0. And then the next letter after n is y, but y is greater than 0 because y is 121. Actually, that's not it. I wanted the capital Y, but 89, right? So that's why technically this is greater than that. So what would happen if you do the lowercase? So in most programming languages, n is actually a higher ASCII character. However, in SQL, or at least this version of SQL, there's no differentiation between lowercase and uppercase. So if you run this, we would actually still get the states. And then if we do the opposite, run, we should get Arizona, California. All right, there we go. Okay. All right, so next we have the arithmetic operators. And so the arithmetic operators are exactly what you think they are. They are the plus sign, minus sign, the multiplication sign, and also the division sign. So you can use these to make calculations on your columns. So let me show you an example. So let's take this one again, and let's say we care about the ID. ID is greater than 5, and we run it. All right, so now we only get cities that have an ID greater than 5. But what you can do ID greater than 5 plus 1, for example. You run it, and then now you only get IDs that are 7 and above. You can add 10 to it. Run it. And there you go. You get ID greater than 15. So that means you only get IDs that are 16 and above. Right? So that means you can add these operators. You could also put on the other side, plus 5. This should give you around the same thing. All right. If we run that. Actually, the opposite. Now it's only 6 and above, because if the ID is 6 and then 6 plus 5, and then 5 plus 6 is 11, 11 is greater than 10, so this returns true, which is why you see that, and anything above will work too. So here's another thing you can do. Let's take out this where statement for now. And now what we can do is let's just look at the columns, ID, city, and state for now. Let's run it. We're going to get 3 columns. Here I am going to add a new column where I could do some funky things, where I will add an operator, an arithmetic operator like 5, and then let's see what happens. I click run. As you can see, I have a new row called question mark column question mark. The reason why is because I did not give it a column name, but the definition of this column is that it is the ID plus 5. Now you have to remember that you can only add values in multiple columns from the same row together using these operators. You can't add a number, for example, from this row and this row, because there's no way of specifying that. You can technically add all rows together or do some fancy things using aggregation, which we'll learn in the future, or windowing functions, or maybe even more things. But for simple select statements, you cannot interact with the other rows. And then let's try to give it a name. Let's try to give column a name. Let's call it a plus 5. Why not? So now the column name should be named plus 5. There we go. Excellent. You could also divide it if you want. I'm not sure if that's useful. As you can see, it's going to give you the quotient, so it's not going to become a float number. All right. And I think that's pretty much it in terms of arithmetic operators. So it's pretty simple. SQL is actually created so that you can query data the easiest way possible. So there's no reason to be complicated, which is great because anyone ranging from programmers to analysts to data scientists, they can all query the same data with ease. All right, so that's pretty much it for SQL operators and arithmetic operators. I'll see you in the next one.